The Phocos FRB Brochure and Design Guide is a simple two-page document that provides basic information about the FRB series DC chest refrigerator freezer and helps you determine the solar array and battery capacity you will need to operate your FRB series refrigerator freezer. The first page of this document highlights several key features of the FRB series, like the new boost switch, which enables faster cooling, or the wide temperature thermostat range, which allows every unit to run as a refrigerator or freezer based on the temperature setting defined by the user. This page also includes a technical data table with specs for each of the FRB series models Phocos offers. When looking at the second page of the brochure and design guide, it's important to understand a few things. First, it is really a simple two-step process to approximate the solar array and battery capacity required. Second, the data on the chart is meant to be used as a guide to get an idea of what materials will be needed to power the Phocos FRB unit you select. The data offered will help to create cost estimates for materials. Next, noted at the bottom, there are standardized ASHRAE test conditions used to provide a level playing field to measure performance for all household appliances. This creates fewer variables to measure energy performance between different manufacturers and models. For refrigeration, ASHRAE defines there is no door openings and no mass, meaning food or liquid inside of the appliance, which aren't real-world conditions, but offer a strong guide. Lastly, the battery recommendations here reflect 3 days of autonomy, or battery storage capacity and operation, if there are 3 days in a row of bad weather and little solar input. So, again, while test standards are required in this industry, it would be good to keep these notes in mind when reviewing the charts for uninterrupted operation to ensure years of reliable solar system performance. If where you live can have weather conditions with no sun for periods longer than 3 days, you may want to increase the battery capacity. This will have to be a choice each customer and solar designer makes to define how many days of battery backup are desired to properly operate your DC appliance year-round. To start the design process, we'll go to the instructions on step number 1. If using San Jose, Costa Rica as our example location, they have an average annual ambient temperature of 72 degrees Fahrenheit. Note that the charts are defined in Celsius, but we do offer a convenient conversion chart to help. When using the conversion chart, we can split the difference between the first 2 rows to have a solid estimate of 22.5 degrees Celsius as the temperature to use on the bar graphs. There are 3 bar graphs to choose from. As you can see, in green, each bar graph represents a different FRB model Phocos offers. The first is a 100-liter capacity, the next is a 230-liter capacity, and the last is a 350-liter capacity. For this example, we will select the Phocos FR350B as the appliance we will purchase. We must decide if we are using the appliance as a refrigerator or a freezer, as the required energy usage will change accordingly. In this example, we will define this appliance will be used as a refrigerator, indicated by the gray bar. We will be between the first and second gray bar on this chart due to our average ambient temperature of 22.5 degrees Celsius. You can see there is not a big difference between the first 2 gray bars. The left axis of the graph is listing the energy consumption as WH per day, or watt-hours per day. So we have one gray bar just hitting 200 watt-hours per day and the second bar just above the 200 watt-hours per day for this region. Our data will be in between, and it would be suggested to take the higher number of 225 watt-hours per day to create a conservative estimate. This is dependent on your personal usage behavior and equipment. Next, we go to step 2 of the chart and find our power draw of 225 watt-hours per day in the first row. Then we match up the solar array size in the second row. With our example, we have to go in between the numbers provided, so we will need close to 120 watts of solar. Next, we look at row 3 of the chart to find the appropriate battery capacity. Again, we have to work in between the numbers provided, but for 3 days of autonomy, we will need approximately a 1200 watt-hour capacity battery bank. For our example, if we want to increase that to 5 days of autonomy because we often get 5 days of weather with no sun, we will divide the 1200 watt-hours by 3 to learn how much capacity is per day. In this example, this results in 400 watt-hours per day. So if we want 2 more days of autonomy, we will add 800 watt-hours of battery capacity. So we will end up with a 2000 watt-hour capacity battery bank. If you were using the Phocos FRB appliance as a freezer, you would follow the exact same steps we just reviewed, but when using the charts in step 1, you would work with the bars in orange instead of gray. Then you would follow with step 2 to define the solar array and battery capacity needed for easy operation. It is always advised to speak with a solar professional about designing a system that works for your requirements, however. This guide only allows for quick estimates. It is important to think about your weather conditions and your energy usage habits when working with the data in this chart. A general best practice is, when in doubt, round up. Phocos is proud to offer the FRB series. This line of DC refrigerators and freezers are robust and efficient. This design tool has been well received in the market, and we hope it helps you make the best decision about your upcoming investment.
For more videos and information, go to www.phocos.com. Phocos, making reliable energy access possible. Anywhere, anytime, any grid.